Good evening, everybody. I hope everyone's doing well. I'm seeing there's a little bit less people today, but that's okay. I'm sure everybody will catch up with us in a little. Oh, there they are. They're coming in very slowly, but so great to see you guys. I did have a while you wait, but because I'm a little bit late, we're not going to be able to start with that. Today, we're going to be learning about geometric patterns. On Monday, we learned about arithmetic patterns. And so today we're going to learn about geometric patterns. Thumbs up. How many of you guys have heard of geometric patterns? Hello, Narisha. Okay, lovely. I'm getting so many thumbs up. I feel like this is going to be an easy task. We're going to get round to doing what we need to do. Okay, lovely, lovely, lovely. Okay. All right, let's start with what we're seeing over here. Let's look at the sequence that ma'am has written on the screen here. Okay, if we look at it, we can very quickly realize that we do not have a common difference. Remember, we learned about the common difference on Monday. We said the common difference is T2 minus T1. T2 minus T1, and we said T2 minus T1 must equal, we must get the same amount as if we took T3 and we minused T2. We should get the exact same thing. But now, in this case, we're not going to get the same thing. 6 minus 2 is 4. 18 minus 6 is 12. 54 minus 18 is something like 36. It's 36. It doesn't give us a common difference. But what have I done to get from one sequence or from one term in the sequence to the next term? Anybody figured it out yet? I'm sure we have. It's quite simple. What have I done to get from one to the other? Good. That's it, short stuff. How much did I multiply by? How much? That's it. We've multiplied by 3. Lovely. So we can't then call that a common difference. It's not a difference. Okay, we don't call it a difference. We call this a common ratio. We call it a ratio. And let's explore why we call it a ratio. Okay, first thing we're going to do is we're going to remember that ratios can be written in 2 different ways. Now, this is grade 8. Let's see who was listening in grade 8. The first way that I can write a ratio is if I go something dot dot something else. Or who remembers how else can I write a ratio? That's it. Lovely. I thought I was going to trick you guys, but I was too good. I was just too good at this. Okay. So I can either write it as one thing dot dot something else, or I can write it as a fraction. One of the two. Okay. For this particular examples that we're doing here, or for geometric patterns, we're going to rely on writing our common ratios as fractions. Okay, but it doesn't negate the fact that it can be written as something is to something. So let's, for instance, take these 2 numbers. If I take 2 is to 6, if I were to simplify this ratio, what would I get? If I simplified the ratio. Good. 1 is to 3, right? I would get 1 is to 3. Now, if I did the same with term 2 and term 3, if I took 6 and 18, if I went 6 is to 18, and I simplified that ratio, again, I'm going to get 1 is to 3. And I can guarantee you, if we go ahead and we take 18 and 54, my ratio will also come out as 1 is to 3. Now, in the case of a common ratio, we're going to rewrite it as a fraction. So how are we going to rewrite it? We're going to take our common ratio, which we denote as R, and we're going to take T2, so the second term, and instead of minusing like we would in common difference, we will divide by T1. But now remember, that must give me the same answer as if I took T3 and I put it over T2. Okay, I must get the exact same answer. And remember this relationship, very important. We're going to use it in an upcoming question. All right, okay. So I want us to take this exact example that we've got over here, and I want you guys to answer these 3 questions. Let me just quickly check, because I can see that many of you have already done this. Thumbs up. Can I leave you guys to do all 3 of these questions on your own? If not, give me a thumbs down. Lerato says, yep. Abu says he'll try. If you're not confident, even if you're feeling like 99%, I'm happy to help. I can stop right here and we can do this question together. Oh, sure, Sanela, no worries. Okay, let's take a screenshot. Personally, I think Sanela just wants to take a picture, like wants to take a screenshot of me in a bagel. But I don't know. Maybe it's the maths, maybe it's the bagel. I don't know. I don't know. R is the common ratio. R is the common ratio. It's on the screen, Abu. Check quickly, right? Okay, now, okay, I think maybe let's do this one together so that I don't lose everyone. Okay, so remember when we were doing arithmetic sequence, we said we always need 2 things when we're doing arithmetic patterns. We need A and we need D. Now, in this particular question, we don't have A and D. We have A, which is always going to be, who remembers what is A? What is A? Common difference. No, that would be D. What does the A stand for? Anybody? Oh no. Which position? Which number in what position, Sanele? And if you take T3 and T7, for example, should it also give you the same ratio, or does it have to be? So Princess, it needs to be the ones directly next to each other. So it needs to be T7 divided by T6, or T3 divided by T2. So the ones right next to each other, because that's how I jump from one to the next. Okay. No, Princess has got it spot on. Asanda has it spot on. It is the first term. It is term 1. It's T1. So let's remember that, guys. Wherever we see an A, that is T1. It's always the first term in the sequence. Okay, always the first term in the sequence. Now, because we're doing geometric patterns, we don't have a D. We're not calculating for a common difference. We're calculating for R. We are calculating for a common ratio. Let me remind you, R is equal to T2 over T1, which should also equal T3 over T2. All right, so let's go ahead and use this, this sequence over here to find the general term that we can do. Okay, we're going to go, let me write A over here. Tn equals, A is my first term is 2, so 2 times my common ratio. How do I get from 2 to 6? I multiply by 3. From 6 to 18, I multiply by 3. All right, so my common ratio is 3, so I'm going to go 3 to the power of n minus 1. Thumbs up. Everybody okay? I feel like as a teacher at MathsLive, you get really tired of saying thumbs up. I say thumbs up all the time, almost every day. Okay, lovely. Okay, remember, Abu? T2 over T1. So the second one over the first one. Just like we did with common difference, T2 minus T1, not the other way around. Okay. All right, so that's our common, our general term. Can I trust you guys? Give me a thumbs up. Can I trust you guys to find the 10th term? Okay, remember N is the position, Narisha. So look at B. B says the 10th term. They want the 10th term. So basically what they're saying is find T10. Do you see how I've replaced N with T, with 10? Sorry, with 10. So that means when I say equals, I'm also going to replace N on this side with 10. Okay, is that making sense, Narisha? Okay, because N tells us, the term tells us what number we are going to find in the 10th position. Okay, that's what it tells us. The number we find in the first position is 2. The number we find in the second position is 6. The number we find in the third position is 18. And the number we find in the fourth position is 54. I want you to tell me, using the formula, which number will be sitting in the 10th position. It's supposed to be big. It should be a big number. That's correct, Abu. Yes, it should be a large number, Princess. Because remember, we're not adding, we're multiplying. So imagine 3 to the power of 9. So it's 3 times 3, which is 9, times 3, which is 27, times 3, which is 81, times 3, which is 108. And then the number just gets bigger, like it's growing exponentially. So it should be a big number. Please don't be scared of that. Okay. Let's not be scared of that. All right. So our answer here should be 39,360. Ooh, guys, the lies. 2 times 3 to the power of 10 minus 1. And if I put that into my calculator, guys, don't put a comma. Please put a multiply. It's too tiny. Let's make it a little bit bigger so people can see. Multiply. Right. I should get 39,366. All right. Let's talk about C. C is a little bit more complicated than we'd like. I'll be honest. But we're going to take it step by step. Now, whenever we see a large number like this, when they say which term is this, what are we replacing that 3,188,646 with? Which part of my general formula? Not n, because n would ask me for the term. That's it, Abu. We're going to take the whole of Tn and we're going to replace it with that number. Narisha, am I making sense? Are we okay? Okay, so if they ask us for the 15th term, then we know that we're looking for T15. So we're replacing n. But if they tell us if they ask us which term is this, then we're replacing the whole of Tn. All right, so let's see what our formula is going to look like now. So I'm going to take the whole of Tn and I'm going to replace it with 3,188,646. So I'm going to go, sorry, let me just write here, C. 3,188,646 equals 2 times 3 to the power of n minus 1. I want to move over a little bit. All right, what are we solving for? What do we want to find in the end? What is the missing, the unknown variable? N. Good. N is the thing that we're trying to solve for. But now I've got a bit of a problem in that my n is part of my exponent. My n is my exponent. So I need to get rid of everything else and ensure that I have n by itself when we are done. So first thing I'm going to do is I want to make sure that the thing that n is attached to is on its own. So I need to get rid of the 2. How am I going to do that? How am I going to get rid of that 2? Divide by 2. Thumbs up. Is everybody understanding what Abu's saying? Everyone okay? Because it's 2 times 3. So in order to get rid of the 2, I'm going to divide by 2 on both sides. So we're going to divide by 2, divide by 2. So that will cancel. So what I should get here is 1,594,323, I believe, if I did my calculation correctly. That's it. Yes. Okay, Didimalo, let's backtrack. Where have I lost you? Me too, Lerato. Me too. Didimalo, I'm not going anywhere. We're going to stop right here. Tell me what I need to re-explain for you to be comfortable. Okay, which part are we calculating? Do you mean B? Do you mean B or do you mean in C? When we're calculating in C or when we're calculating in B? Question B, question C. the position n. All right, okay, let's go back to the wording, because I think the wording is the most important part. Okay, I want you to look at the difference between the way question B and question C is worded. All right, so question B says they are looking for the 10th term. Do you agree with me that 2 is the first term? This is the first term. Yes, we happy with that? Right. So when they say to us they want the 10th term, what they're actually asking us for is T10. Happy? Okay, just give me a thumbs up if you're happy with what I've said here. Lovely. Okay, good. So we know we're looking for T10, right? So we're going to go into our formula and we're going to go T10 equals, and then we're going to replace everything with 10, and then we're going to get an answer. So T10, or the 10th term, is 39,366. The 10th term is 39,366. Now, in this case, they're asking us which term is that. So they've given us the answer, because technically this part turned into that answer. So in C, what they're asking us is T something is equal to 3,188,646. Tidimalo, what would normally be sitting there? What letter would normally be sitting there? N, exactly. So if you look at the way we've now done it, we are now taking the Tn part, we're taking the whole of the Tn part, and we're replacing it with the answer we would get, and then we're working backwards. So if you look at this formula, I can rewrite it again. Let me do this. Let me rewrite it. I'm going to say C. Tn is equal to 2 times 3 to the power of n minus 1. Now, in this case, I know what my Tn is. They've given me Tn. They've told me that the answer I will get out is 3,188,646. So I can go and take this Tn part, and I'm going to replace the whole of Tn with that number. Okay, thumbs up. Am I making sense? Good. Okay, because they're asking me, they've given me the answer. They want me to find the position. That's it. Then we equate, correct. And then we'll say 3,188,646 equals 2 times 3 to the power of n minus 1. And now we can see that we're solving for n, because the n part will tell us T. At that T whatever, we're going to find that number. That's what we're going to find. We're going to find 3 million at that T whatever. Okay. Okay, good. So now we're at this point. What is our next step? Remember, we're trying to solve for n, and n is in my exponent. My next step is going to be to get rid of that 2, because my n is attached to 3. So I want this thing on its own first. So what I'm going to first do is I'm going to get rid of 2. So I'm going to divide by 2, divide by 2. Okay, are we all together, everyone? Yes? Lovely. Okay, and now we are going to divide. We're going to get 1,594,323 as an answer, and that is equal to 3 to the power of n minus 1. But now I've still got an issue in that my n, the thing that I'm trying to solve for, is still in my exponent. But I know that if I want to compare exponents, I need the same what? Absolutely, Abu, you are spot on. If I want to work with my exponents, yes, princess, we need the same base. So what are we going to do with this 1,594? I'm going to pick up my trusty calculator, because thank the Lord we are in grade 10 and we don't need to prime factorize. That's it. And then we're going to enter the number, and we're going to click equals shift fact. Everybody, then you'll tell me what your calculator says. And Abu, you're spot on. That's exactly what the calculator. That's it, Narisha. Keep going, guys. Ah, guys make me proud. Good. On this side, we're going to get 3 to the power of 13 equals 3 to the power of n minus 1. And now that I have the same base, I can drop my bases. Drop the base. Drop the base. And that tells me that 13 is equal to n minus 1. Therefore, transpose that negative 1 over to the other side, it becomes positive 1. Therefore, n is equal to 14. All right. How did we do? Yes? Okay. Shall I give you another example to try? Can we do it? Yes? Okay, I can zoom out. Sure, no worries. I can zoom out Sanela. I think Sanela just wants to take screenshots of everything. Does that help? Tell me if that's helpful. Yo. I do, yes, absolutely. Yes. A sweet for you, Narisha. Yes. Narisha remembers. I love this. Absolutely. Ish, Abu, let me tell you something, hey. In all honesty, I left Afrikaans where I left Afrikaans. I can't help you. I can't help you. I'm gonna be honest. Like the only thing I remember about Afrikaans was die hond blaf, die kat meow. That's as far as I remember about Afrikaans. From that point on, like ish. And then, die blow fan ons here. Yeah, that's as far as my Afrikaans goes. And then after that, I'm so sorry, Abu, you're on your own. You're on your own. Om te beklim doen. Hi, guys. Whoa. Okay, all right. Let's work on another example. Let's see what you guys can do with this. All right. So I'm going to say determine A, the general term. The general term. B, the fifth term. The fifth term. And then C, I'm going to ask you, give me a second. I'm going to. Okay. And then I'm going to say which term is 8,748. Here is your sequence. 4, 12, 36, ... 108, ... All right. So remember, guys, when we're finding our general term, we need two things. We need A and we need R. Okay, and I'm just going to, for good measure, Tn equals A times R to the power of n minus 1. All right. Can I give you guys 4 minutes? Yes. Let's do 4 minutes. Pumzile, where on earth have you been? All right, peeps, 4 minutes and counting. We're almost at 3 minutes. Okay, good, Sanele. You're absolutely correct. But remember, you haven't replaced Tn. So your formula must still say 4 times 3 to the power of n minus 1, because we're not replacing n yet in A. We only replace n in B. Do you understand what ma'am is saying? Oh, I'm so sorry, Pumazile. Okay, cool stuff. All right, that's it. That's the one. Nicely done, Sanele. Okay, then for the 5th term, you need to find me T5. So now you're replacing N with 5. So find me the answer there. Okay. Ooh, I almost broke my phone because Pumzila is also breaking his phone on that side. Sure, I've got 2 different answers. Narisha's is different from Sanele's. Let's see. Let's see if everybody else can get the other one. That's it. That's it. Okay. Sorry, guys. I'm just trying to answer the other team members, the other MathsLive team members very quickly. Give me 1 second, guys. Very important. I'm very busy and important. I just need to make sure that I'm doing all the right things, that I don't make a mistake here while we're busy. That's it, Narisha. Beautiful work. All right. All right, peeps. Shall we look at how you guys got to all these lovely answers? Yes. Let's have a look. All right. I'm just going to make this a little bit bigger. All right. So the general term, nice and easy. I just need to figure out how I got from 4 to 12 to 36. That's still times 3. Times 3. So A is always my first term. So A is 4. And my common ratio is 3. All right. So my general term, A, we will go Tn is equal to, my A is 4 times 3 to the power of n minus 1. I have not replaced n yet. It's just a general formula. Okay. Then for B, I now want the 5th term. So I'm going to write T5 is equal to 4 times 3 to the power of 5 minus 1. Okay, let me just see. I hope you guys aren't lying to me. 4 times 3 to the power of 4. 4 times 3 to the power of 4. 324. Okay, yes, good. 324. All right. In the next one, which term is, so we're going to take the whole of Tn and we're going to replace it with 8748. So for C, we're going to go 8748 equals 4 times 3 to the power of n minus 1. Now, I want n. Therefore, I must get rid of the 4 first. I'm going to divide by 4, divide both sides by 4. Right. So 8748 divided by 4 will give us 2,187. So 2187 equals 3 to the power of n minus 1. And then I'm going to go to my calculator and I'm going to go 2187 equals shift fact. And that gives me 3 to the power of 7. So I'm going to get 3 to the power of 7 equals 3 to the power of n minus 1. And now that I have the same bases, I can drop my bases. Therefore, 7 is equal to n minus 1. Therefore, n must equal, transpose your negative 1 over to the other side. N is equal to 8. How did we do out of 3? Did we get 3 out of 3? Yes. A sweet for Abu. Yay, for dropping the base. Well done, guys. Amazing stuff. Well done, Sanele. I know this is kind of like a bit of a tricky one, and we need to, learn how to do all the steps and things. We need to remember exponents. When was the last time we did exponents, Lord? But we're going to have to remember they're coming up in your final exams coming up very soon. Okay. Sorry, Narisha. I'm sorry for bringing up unsavory things so close to the school holiday even. I'm not being very nice. Okay. All right. Shall we look at a bit of a challenge? Yes? Let's look at a little bit of a challenge. Sorry, Narisha, it's unfortunate that the verdict has already been determined. We are going to look at a bit of a challenge. All right. I want us to focus on this question over here. Okay. Can I ask everyone to take this question, number 6, or whatever we want to call it? I want you guys to please find me the general term. Find me the general term, please. Okay. If you're done, you can either put an emoji on the screen or in the chat, or you can find me, or you can just write the answer in the chat for me. Okay, Abu's definitely got it. Okay, Abu's got the right idea. Remember, we always need 2 things. We need A and we need R. Narisha, why are you saying no? We need to work. Oh, lovely. Princess has got it as well. All right, let's look. Okay, I can tell my A is 3. And my R over here is going to be, now if I take T2, that's negative 12 divided by 3. That's going to give me an R of negative 4. 48 divided by negative 12 will also give me negative 4. So if I were to write my general formula, I would do this. I would go Tn is equal to 3 times bracket negative 4 to the power of n minus 1. Anybody want to explain to Teacher Coco why I've emphasized the fact that I need that negative 4 in brackets? Who can tell me? I think that's Narisha's go-to. Narisha's go-to is always, it has COVID, ma'am. It's not because it has COVID. Shall we do a little grade 7, grade 8 exercise? Or I see somebody might have an answer for me. To show that the exponents remains outside and doesn't happen in the bracket. Yes. To indicate multiplication. Yes, we're definitely multiplying, Tidimalo. Abu, I'm not going to accept your answer. I understand what you're saying, but it's not answered correctly. All right, let's do a little bit of a thought experiment here. If I say to you guys, put onto your calculators negative 4 to the power of 2. Exactly like that. Put it into your calculator and tell me what your calculator says. The way that we're looking at on the screen. Good, Narisha. Your calculator will say negative 16. Now, do that. Negative 4 in brackets to the power of 2. What do I get? I get positive 16. All right. I get positive 16. Now, if you look at our sequence over here, our numbers or the numbers in the pattern are alternating positive and negative, right? So this first one is positive. The next number is negative. The next number then needs to be positive, and the next number then needs to be negative. Now, if we leave our negative 4 sitting like that, all my answers are just going to come out negative. All my answers are going to come out negative. But if I put a bracket around it, what your calculator does is it registers that as negative 4 times negative 4. This one over here at the top does this. It goes negative, and then it goes 4 times 4. And then it does the 4 times 4, and it adds a negative, and that's why we get negative 16. But now if we do this for all of them, I'm just going to get negative 16, and the next number will be negative whatever, negative whatever. So in order for us to alternate the positive, negative, we need to ensure that we've got it in a bracket. Okay. Thumbs up. Is everybody understanding what ma'am means by the fact that we must, whenever we have a negative common ratio, we need to ensure that it stays in the bracket. Otherwise, all our answers are just going to be negative, and we're not going to get out of this what we need. All right. Exactly, Abu. If COVID was not in a bracket, it would always be negative. But now we know that we always get positive cases and negative cases, so COVID must go into a bracket. You understand? You understand? Exactly. It's quarantined. We are quarantining the COVID. You know what I mean? We're quarantining the COVID in a bracket. All right. Yeah, there we go, Asanda. That's the one. All right, lovely. So our general term over here is going to be Tn is equal to 3 times, and then in brackets, -4 to the power of n minus 1. All right, let's go look at a challenge. All right. I'm going to give you guys a challenge very quickly. Okay. Determine the common ratio if T4 is equal to 108 and T7 is equal to, let me find it for you. Give me a second. 2196. T7 is equal to 2196. So we want to find the common ratio. Does this look familiar? I'm glad. I'm glad. Do we remember what we did? Who remembers when we were doing arithmetic patterns? When we were not given our A and we were not given our common difference, our D, what did we do? What did we do with the information when it was given it to us in this manner? What are we dividing by? What are we doing? What did we use? I will remind you guys. Something equal. That's the one. The spelling is terrible. The spelling is terrible, Narisha. I have to be quite honest. The spelling is not the best. But I understand what does everybody understand what Narisha's written in the chat? Yes? Yeah. No? Okay. So what Narisha's trying to say, and very correctly, is what Sanele has written correctly in the chat now. Simultaneous equations. There it is. Okay. Simultaneous equations. Remember we did this? We said T4 ... equals 108. And then we said T7 ... equals 2196. And then we worked our way backwards, right? So we're going to do exactly that to solve for the common ratio. So we want to find R. Now remember, guys, we always take the bigger number first. We take the number in the furthest position first. So I'm going to start off. I'm going to say T7 ... something equals 2196. And then I'm going to name this equation 1. And then I'm going to go T4 ... something equals 108. And I'm going to name this equation 2. Now, remember what goes in here. We know that our general term says Tn equals A times R to the power of n minus 1. So that's what we're going to put in here. But remember that we have now replaced our n with 7. So we're going to go onto this side of our equation, and wherever we see an n, we're going to replace it with 7. So we're going to go A times R to the power of 7 minus 1. Okay? And then I'm going to do the same thing down here. I now know that I've replaced n with 4, so I'm going to do the exact same thing. A times R to the power of 4 minus 1. And then we're going to clean these up. Before I continue, is everybody understanding what ma'am has just done? Thumbs up if yes, thumbs down if I need to explain again. I'm hoping I'm jogging your memory from what we did on Monday in terms of arithmetic patterns. Okay, lovely. Let's clean these up. Let's make them look a little bit better. Okay, let's make it look a little bit better. So I'm going to take equation 1, and I'm going to rewrite it as a times r to the power of 7 minus 1 will give me 6 is equal to 2196. And then equation 2 would give me a times r to the power of 3 equals 108. Now I'm going to draw a line. Remember, we need to draw a line. But when we were doing arithmetic sequence, what came next? Yes, good, Abu. If we were doing an arithmetic sequence, we would minus. We would say equation 1 minus equation 2. And the reason we minus is because we are using the common difference. But this is not a common difference. What are we using in this particular question? We are looking for not the common difference, we're looking for the common what? Anyone remember the common? What does the R stand for? The common what? That's it, Sanele. The common ratio. We're looking for the common ratio. How do we look for the common ratio? Do we remember how we look for the common ratio? We're going to say R is equal to T2 divided by T1. Thumbs up. Are we all in agreement here? We take T2 divided by T1. So in this case, instead of saying equation 1 minus equation 2, we now need to say equation 1 divided by equation 2. Is ma'am making sense? Are we all good here? Yes, we need to divide. Of course we must, because we're finding the common ratio. So let's go ahead and do that. Let's go ahead and divide. So I know my instruction is equation 1 divided by equation 2. So A divided by A will just give us 1, or in this case, they cancel each other out, right? R to the power of 6 divided by R to the power of 3 will leave us with R to the power of 3. And this is equal to 2196 divided by 108. Somebody punch that into a calculator. Give me an answer very quickly. 61. Abu, check again. Check again. It's not 61 over 3. It should not be. What should we get, guys? Is it 61 over 3? Oh, it's because ma'am wrote the number wrong. I'm so sorry, guys. The number is 2916. I'm sorry, guys. A thousand apologies to everybody. I'm so sorry. Everybody, please change the number to 2916. I'm so sorry. Guys, it happens. It happens. Yeah, I'm so sorry, guys. There it is, Sanele. That's the answer I'm looking for. Not whatever. And I'm so sorry, Abu. I understand that you did the sum so beautifully. I was testing you guys. Okay, it's 2916. And if we divide by 108, we will get 27. And that tells us that our common ratio, R, is equal to how much? What to the power of 3 is equal to 27? That's it. R is equal to 3. Everyone in agreement? R is equal to 3? Lovely. There we go. R is equal to 3. All right. I'm going to give you guys one to try on your own. Okay? Yes? Okay. All right. I'm going to say determine R if T2 is equal to 10 and, just give me a second. All right. T2 is equal to 10. All right, and T6 is equal to 160. Okay, remember the steps that we took, guys. Should I put the steps on the screen? I'm going to make this a little bit smaller, and then I'm just going to put that question above it so that we can remember exactly what we're doing. So this is the question we're answering right now. This is the method we used for the question right above. All right, I'll give you guys 5 minutes. This is a big one. Correct. If we want to find A and we want to find the general formula, we can just sub R into one of the equations. See, now I'm chatting. Abu, I can now understand why you do IT, because you just have a computer brain, like the fastest brain I've ever seen. It's impressive. It sucks a little bit that it's not that great at Afrikaans paper 2 and English paper 3, but but it's definitely good for maths and IT. I'll tell you that. You do excellent work. Well done. It is nice. I love it, but it's because I'm also a maths and an English teacher. Those are my 2 major. Well, I have 4 majors actually, but that's beside the point. Yes. So I studied maths, physics, and English, and I also studied psychology, which I really love more than most things, except maths. Maths is my first love. I do, Abu. It is tough. It is tough, but you get through it. Okay, I don't know how to feel. I don't know how to feel about that. It's hilarious. It really is. You've made my evening, but oh, I love it. Oh, oh. Okay, I'll give everybody else who's not looking for a rich husband 1 more minute. A rich husband or wife. I'll give everyone else who's actually going to go to school 1 more minute. Oh, you guys crack me up. You guys make my day. I love it though. I do. It did. It moved so fast, Asanda. You know what I think? I think when you're learning something new and you're enjoying what you're learning, time moves really, really fast. And especially when you understand how to do it, it makes it so much nicer. Yes? I think so. Yeah, I feel like that happens quite often. Yeah. Guys, you won't even want to. You want to work for yourself. Trust me, you will. Okay. All right, Lerato. I concede. Hi, Bo, Narisha, what are these things that we are hearing now? Hi. All right, guys. Okay, let's look at the answer and let's just, let's just see about what's happening here. Okay, I'm going to zoom in a little bit, and then we're just going to do some touch-ups to make sure that this thing works. Okay, so we're going to start with the big number. T6 ... Okay, something equals 160. That is equation 1. And then T2 ... something equals 10. ... equation 2. All right. Then we know our general formula, Tn is equal to a times r to the power of n minus 1. We're going to take this side of the equation and we're going to insert it in that open space. So we know we've replaced n with 6 in this question. So we're going to go a times r to the power of, I'm just going to go ahead and take a shortcut. 6 minus 1 will give me a to the r to the power of 5. And then over here, t to the power of 2a times r to the power of 2 minus 1 will just give me r to the power of 1. All right. And then we just do a little bit of minusing, right? So, oh, not minusing. I'm sorry, guys. We are dividing. Equation 1 divided by equation 2. So the a's will cancel each other out. R to the power of 5 divided by r to the power of 1 will give us r to the 4 is equal to 160 divided by 10 is 16. And then we'll just take the fourth root of both sides. So the fourth root of 16 is just 2. R is equal to 2. Did we win? Yes. Did we manage? Yay. So Princess, we always want to make sure the number or the term with the bigger number sits on the top. Okay, I'll show you why we want to do this. It's not that your answer would come out wrong if we did it the other way around. It's just that you're going to have to work with fractions, and it takes a lot longer for you to get to the answer. Okay, let me show you what I mean. I'm going to move over to the side here. So if I did it in the opposite direction, if I did this, if I said T2 first, if I said T2 dot dot a to the power of times r to the power of 1 is equal to 10, and then T6 a times r to the power of 5 is equal to 160. When we divide, because this is now equation 1 and equation 2, we would still say a divided by a is a. Now, r to the power of 1 divided by r to the power of 5 would give us r to the power of -4, which is equal to 10 divided by 16 would then give us 1 over 16. And then it makes it messier. Do you see that? It makes it messier because now we have to go r to the -4 is equal to 1 over 2 to the power of 4. And then we'll have to go r to the -4 is equal to 2. I'm going to take that to the top, so that becomes 2 to the power of -4. And only then can I say that r is equal to 2. So this is what I'm avoiding. See what ma'am is doing? I'm making it a little bit easier for us to not have to do extra steps. You get what I mean, Princess? Yeah, we all good. We always want to make sure the bigger number is on top so that when we divide or when we minus, our answer stays positive and we don't have to work with like negative numbers, put this one inside this one. Yes, this one is messy. Let's stick to the other one that we were working with. This one, where all our answers are positive and everything works out nice and hunky-dory for us. All right, this is where the lesson ends today. Okay. This is where the lesson ends today. I'm going to post up the quiz in the next minute. So please, please go and try today's quiz. I've made it a little bit easier because these concepts are quite challenging. They're quite tough. And I want to make sure that we get the basics right because the extension stuff, not so great. Oh, thank you. Very cutesy, very mindful. Yes. Okay. Who wants to take home a challenge? Thumbs up if you would like a challenge to go and try. Nobody wants a challenge to try? You can just play around with it. You don't have to do anything with it. Just see if maybe you can answer it. Not today. You don't have to do it today, but you can try it. Okay. I want you guys to try this. Try this question here if you've got the chance. I want you guys to find me the general term of this equation.